Welcome to the channel, and today we are going to discuss dimensional analysis. I thought this was very important as you are going to revise your exams. Take note that this dimensional analysis is very important in fluid mechanics. We're going to discuss how to solve questions involving dimensional analysis. I'll start with explaining what is Buckingham Theorem. The Buckingham Theorem The Buckingham Theorem states that if there are n variables in a dimensional homogeneous equation and these contain m, l, t, then the variables are arranged into n minus m dimensional terms. Then these dimensional terms are called pi terms. There are basically three important points to take. These are MLT for mass kg as the SI unit, length SI unit is distance, time is seconds SI units. Using Buckingham theorem, show that discharge Q is given by Q is equals to n d cubed as a function of u over p n d squared is also a function of key surface tension p n squared d cubed. You're supposed to solve that question. I'll quickly move into solving the equation, and then we're going to start by writing all the elements of the equation: d for internal diameter, n for rational speed, p for density, u for viscosity, q for surface tension, and w for specific weight. The number of variables are 7. Therefore, the number of pi group dimensional is 7 minus 3, which is 4. Individual dimensions are d, diameter is equals to length, rotational speed is t minus 1, density, the SI unit is ml minus 3, u, which is viscosity, is ml minus 1, t minus 1, q, which is ml minus 2, w, which is ml minus 2, t minus 2, q, which is l, 3, t minus 1. Repeating variables are d, n, and p, which must contain both m, l, and t terms. Take note of that. It must contain m, l, and t terms. Let's move to the next page. Then you're starting to solve the equation. Pi group 1. Pi group 1 is made up of the repeating variables plus 1 function or another unit that is not repeating. So we're going to equate it to ml minus t. ml is equals to the terms, which is la minus 1, t minus b, ml minus c3, ml t minus 1. So we're going to equate all the values to 0. 0, m, l 0, t 0, and then you find the equations. You're going to substitute all the equations in the written below. So find that d minus 2, n minus 1, p minus 1 is u. So to get the first dimensional group, which is u, d squared n minus p. Note that you should be able to know how this one is really gotten, because these ones have -1, -2, therefore it becomes the denominator and u becomes the numerator. We then move to We then move to pi 2, which is dA as solved below. We then substitute all the terms of m, l, and t. You get that this is raised to -3, n -2, p -1 and then you get surface tension. As I told you earlier, surface tension becomes the numerator. The terms with negative become the denominator. So it's as shown below in this. The dimension group 3 is also gotten like what we've done in 1 and 2. We get, after substituting all the numbers in the MLT, you get that d -1, n -2, p -1, w. You get this. It's w d squared over. Then you're also supposed to solve for d4 and for pi 4. As you substitute the terms, you'll get this. Then we'll move on to proving that this is, after getting all the equations, we're supposed to write something like this for pi 1, pi 2, pi 3, and pi 4. Then we're supposed to prove that this, the first equation, is supposed to look like this. As you can see, we've already proved that. Not that we've taken this, the first one, and taken it out to get it q. So q becomes this is equals to nd cubed is a function of all these pi groups. Then we have solved the equation. Another point to note that method of selecting repeated variable should contain geometrical flow and fluid property and geometrical property. This include length, distance, height, etc. Flow property. This include velocity, acceleration, etc. Fluid property. This include viscosity, density, etc. Most fluid problems choosing repeating variable are dVp, LVp, LVu, dVu. I hope you've gotten something from this video. Ensure you subscribe to the channel for more informative videos as you continue revising for exam. Thank you.